Welcome to the next lecture on the series on functions. Now, having looked at the concept of when is a relation called a function and what are the kinds of functions that we deal with, that is the one-to-one or many-to-one function. Now we are ready to discuss the next big thing, which is called the domain and range of a function. Right, so we have to look at what is the domain of a function and what is the range of a function. Because once we understand the domain and range, it again allows us to be able to write the inverse of a function, to be able to make a composite function, and also look at many other things that opens up once we have a very good idea of the domain and range of the functions. So let us dwell into this and go deeper into the idea of domain and range. Now, what is the domain of a function or a relation for that matter? Domain of a relation, or I can say a function, is a set of values of x in the relation. So whatever x can take the values, possible values of x is called the domain of that function. And the possible value or the set of values of y in that function, that means the values that the function can take or the fx can take if it is a function of x, is called the range of a function. And range will obviously depend on the domain because output depends on the input to any function or any machine for that matter. So domain is the set of possible values of x. And therefore, we should be very clear about the algebra of different kinds of function so that we can know which values are allowed for a given function, which are not allowed. And the allowed values or the set of those allowed values is called the domain. Now, if I show you a function here, or we go to another function here, let's see this. Fx is equal to 2x minus 1. X belongs to the set of real numbers and x varies from minus 1 to 3, where minus 1 and 3 are also included. So the domain of this function is x varying from minus 1 to 3 and minus 1 and 3 included, because this is the values for which this function has been defined. The definition of the function is itself saying that x can vary from minus 1 to 3. So domain of this function is already given in the question. And the range is the output values. So if I input minus 1 into this function, I get 2 times minus 1, which is negative 3. And as you can see, if I go on increasing the x from minus 1 to 3, 2x minus 1 is going to increase. Therefore, the minimum value of fx is negative 3, and the maximum value will be when I input x equal to 3. So 2 times 3 is 6, minus 1 is 5. So range means the y values will vary from negative 3 to 5. So depending on the input or the domain values or the domain of a function, we can also find the range if the function is given or very clearly defined. So we can see here domain is from minus 1 to 3 and range is from negative 3 to 5. Now, sometimes the graph of a function may be given and the form may not be given. I mean, fx equal to the definition of the function, the mathematical form is not given, but the graph is given. In that way, how do we write the domain and range? Now we look at the graph and see that the x can vary from a to b here, where a is a lower value of x and b is a higher value of x. So domain of this function is x varying from a to b, where a and b are also included, because you can see this is a what is called a dark circle. If it is not dark, then we will not write the sign of equality in the domain. Now looking at the range, where are the y values varying? Y values are varying from c to d. Right? This is the minimum value of y for this function and this is the maximum. As x varies from a to b, y varies from c to d. So the range of the function is c less than equal to y less than equal to d. So this is the idea about the domain and range. But as we said, some of the values that are allowed. So we should know now which values are allowed and which values are not allowed for different kind of functions. And this opens up an entirely different chapter on domain and range. And therefore, the algebra knowledge is very important here. Now, if I give you a function x square, you know that x square has no restriction. If fx equal to x square can be calculated for any x, whether it's negative x, positive x, or 0. So the domain of this function is x belonging to all real numbers, or you can say The domain is from minus infinity to infinity. Okay. We can also say all the x values are allowed. That means the domain is from minus infinity to infinity. For a square root of x, square root can only be taken for positive values of x or 0. So we can't input negative values into a function which is fx equal to root x. Right? Negative values can't be inputted. So the domain is x greater than equal to 0. You have to be very, very particular about certain kinds of functions which have restrictions. So this has restriction. First function is a restriction. Second, 1 over x. Now you know the denominator of a function or any matter in, or anything in mathematics can't be 0. Therefore, x can't be 0. All other values are okay. You can also say define this as x belonging to R slash 0. That means 0 is not allowed. Except 0, all the x values from minus infinity to plus infinity are allowed. So in case the x is in the denominator or any form of x is in the denominator, then that form cannot become 0. So we have to see which value of x can make the denominator go to 0 and therefore avoid that value in the domain. Third is you have a combination of 1 and 2. You have square root, you have denominator, both have been put in this one. Now you have square root also and you have denominator also. So x now can't be even 0 because 0 is not allowed because of denominator and negative values are not allowed because it is square root. So the domain is only x greater than 0. That means positive value of x, also called R plus. Positive real values of x are allowed to be inputted in this function. Now, based on this, let us try to write the domain of some of the functions that I have here with me. We try to write some of the definitions here, some of these, the domains here. Let us look at that. Yes. And I have a few questions where we can work this out, or we can even look at this one. State the domain and range of the function. Let's focus on the domain as of now. We have square root of x plus 6. Now it is a square root, and therefore, as we have seen, square root can be negative. So x plus 6, therefore, has to be either 0 or greater than 0. That means the domain is x greater than or equal to negative 6. The domain of this function is. Second, 1 over x square, and there is a denominator x square is appearing and x can't be 0. Right? So the domain is x not equal to 0 because that makes the denominator go to 0. Third, 1 over x plus 1. Now what is the term in the denominator? X plus 1. So x plus 1 can't be 0. So x can't be negative 1. So the domain of this function, x can't be negative 1. Or you can say all real values except negative 1. Only negative 1 is not allowed. Rest all everything is okay for the domain. Minus 1 over root x. Again, x is in the denominator as well as square root. So it has to be x only greater than 0. 3 minus x in the denominator. 3 minus x can't be 0. So x can't be equal to 3. Under root of 4 minus x. 4 minus x has to be either 0 or more than 0. It means 4 has to be greater than equal to x. It means x has to be less than equal to 4. Is it right? So that is how the domain of the function can be worked out. Now, what about the range? Range is a set of y values which we will get by inputting the x values in the given function. So if I input minus 6 or more than minus 6 in this function, what am I going to get for the range? It is going to be y will be either 0 or greater than 0. Because when I input minus 6 plus 6 is 0, square root of 0 is 0. So I will get 0 or a positive value of y. 1 over x square. Now 1 is a constant, right? And x square is a positive number always. So are we going to get always a number which is greater than 0? 1 is positive, x square is always positive. Positive over positive can only give us a positive answer. So y is greater than 0 is the range of this. X not equal to minus 1. That's okay. But what is there in the numerator? 1. And 1 can't be 0. So can y be 0? Can we have any value of x where this can become 0? Isn't it? So 1 over x plus 1, if has to become 0, then 1 has to be equal to 0, which is not possible. So y can't be 0. That is the range of this function. All other values we can get as the output of this function from minus infinity to infinity, but we can't get 0 from this function. Minus 1 over root x. Root x, as we said, is allowed is x greater than 0. The domain, if x is greater than 0, then root x is positive. Therefore, y will be here less than 0 because there's a minus 1 in the numerator. And for the last one, or the second last one, 3 minus x, if x is not equal to 3, then we have again 1 in the numerator, and therefore y can't be 0. And for the last one, if x is to be less than equal to 4, then I'm going to get y either 0 or greater than 0 as the output of this function or the range. Right, so this is how we can work out the domain and range. And in the next video, I will take up more functions. And we will try to look at some more functions like the quadratics and some other functions, rational functions, where we will work out the domain and range again. Thank you very much.